dear student, in last section we discussed the derivation of boiling point. This is the derivation of boiling point and its relationship to lowering of vapor pressure and molecular mass. And here the final equation we get the Kb is equals to this is Kb is equals to R T naught square. Kb is equals to R T naught square divided by LV into 1000. This is the final equation. This equation is 10. Equation number is 10. After here I discussed in the last class. In today's class, I am going to discuss about the boiling point of elevation as a colligative property. Boiling point elevation as a colligative property and the relation between. I already told in last section, in last class, the finding molecular mass is the relationship between molecular mass and elevation in the boiling point equation. Here, boiling point elevation is a colligative property. It is colligative property or not a colligative property. This is a colligative property. Here, I write here the boiling point. The boiling point elevation as a colligative property. The boiling point elevation is a colligative property. This is very important for 1 mass question. This is a 1 mass question. Boiling point elevation as a colligative property. Here it is the boiling point of elevation is a colligative property or not a colligative property. Here this you take the equation, the following the equation number 7. Equation number 7, what is it? The equation number 7 is delta T is equals to R T naught square. Delta T is equals to R T naught square divided by LP into N by V. Or therefore it is also written as here delta T is directly proportional to N by directly proportional to the N plus proportional to the capital N. Here the delta T is directly proportional to the N by N. This is equation number 7. This is equation number 7. Here the equation number 7, that is the boiling point elevation in a dilute solution. This boiling point elevation in a dilute solution. Here the dilute solution is taken as here N by N. See the rho slope of the dilute solution is P naught minus T divided by P naught. This is the N by N. This is dilute solution equation. This is directly proportional to this elevation in a boiling point. Solution here, that is the boiling point elevation in a dilute solution is directly proportional to the number of moles of a solute dissolved in a given amount of solvent. When the number of moles of solute is dissolved in a given amount of solvent and is independent of nature of the solute. This is the independent of the nature of the solute. You know the colligative property definition. Here the independent of the nature of the solute. It is depend only on the nature of the solvent. The independent of the solute and the boiling point elevation is a colligative property. when asked in examination, this boiling point elevation is a colligative property? Question mark. Here. You write the answer is, you take this equation, you consider this equation, delta t is equals to r d naught square divided by n v into n by n, or you can write this equation, delta t is proportional to n by n. The answer, you take this equation and you write explanation, that is the boiling point of elevation in the dilute solution is directly proportional to the number of, here solution is directly proportional to the number of moles of a solute is dissolved in a known amount of solvent and is independent of the nature of the solute. Hence, the boiling point elevation is a colligative property. This is the answer for 1 mark question. This is the 1 mark question. Okay, next, the relation between molecular mass and elevation in the boiling point. Relation between molecular mass, relation between molecular mass, the relation between molecular mass and elevation in the boiling point. And elevation in the boiling point. Elevation in the boiling point. I told already this relation between the molecular mass and elevation in the boiling point. Here, by measuring the boiling point derivation of a solution, by measuring the boiling point derivation of a solution of known concentration, it is possible to, when it is known concentration, it is possible to calculate molar mass. Molar mass, it is a molecular mass. It is when you know the concentration of here the derivation of a solution of a known concentration, it is possible to calculate molar mass of a non-volatile, or it is a non-electrolytic solution. Here consider the equation is delta T is equals to R T naught square capital small w divided by LV capital W into here another molecular mass is this equation number is last will be derived in a solution. This equation number is 8. See in last derivation, the delta T is equals to R T naught square W divided by LV capital W to N. This is the equation number 8. Here the equation number 10 and we have KB is equation number 10, that is KB is equals to R T naught square divided by LV into 1000. LV into 1000. Okay, this is the equation number 10. And here the M is equals to We are considering this equation and the equation 10 and 8. This is equation. We have the finally equation here, the 11 equation or T naught square or T naught square. This to practice the derivation of lowering of vapor pressure. Elevation of boiling point to the lowering of vapor pressure. Here R M is equals to R T naught square can be a small w divided by LB into capital. So R you can write here. It is in place of KB delta T LB capital. Here, equation number 10 and 11, you get finally the finding molecular mass of a cell. Here, this is a relation between the molecular mass and elevation in the boiling point. Here, the molar mass of non-volatile solute or non-electrolytic. Sorry. This is M is equals to R T naught square W divided by delta T LV into capital W. The final, this is the equation number 11 and finally we get the M is equals to this equation. You use the calculating the molecular mass of a solid. Here M is equals to Kb. M is equals to Kb into capital small w into 1000 divided by delta T capital. This is the final equation for the relation between molecular mass and its elevation in the boiling point. Next study. Determination of elevation in the boiling point by Landberger's method. This is very important. The whole colligative property unit is very important in this. In this unit here, the determination of elevation in the boiling point. Heading determination of elevation in the boiling point. Elevation in the boiling point. Elevation in the boiling point by Landberger's method. By Landberger's method. Here, the determination of elevation in the boiling point by Landberger's method. First of all, I draw diagram for this method for the determining the elevation of the boiling point by Landberger's method. Use scale pencil, draw neat pebble diagram. You know diagram, you automatically explain easy. It is very easy to explain the method of the for determination of elevation the boiling point. This is a flask. Can simply try here. You use scale and pencil, draw in level diagram. Okay, this is the diagram for the determination of elevation in the boiling point by Landberger's method. You draw neatly this diagram, you draw neatly. I draw this roughly, I draw this diagram. Here, this is a here. This is flask. This is a flask A. Flask A, this contains salt. Here contains salt. And here, this is a safely tube. Safely tube. This one. This is a safely tube. And here, heating takes place. This is heating. And this is a delivery tube. Take up to here this one. This is a delivery tube. Delivery tube. And this is a rose head. This is known as rose head. Rose head. And this is a small one. Small hole, and this is a inner tube. Inner tube. Next, or it is a inner tube, or it is also known as a graduated tube. Graduated tube. Graduated tube B. Graduated tube B. Okay. Another, the outer vessel. This is the outer vessel. Outer vessel D. This is the outer vessel D. And another is a thermometer. This one is known as a inner tube or graduated tube. This is a outer vessel. This is a thermometer. This is thermometer. 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 is a safety tube. This one is a safety tube, and this is a flask A. It contains here. This is the presence of water. That water is a salt, and this is known as this one. This is known as a delivery tube. Next, and here this one here the small hole is present here. The small hole is represented as H, and here this is a inner graduated tube. Inner graduated tube, it is written as B here. Sorry, inner tube, or it is also known as a graduated tube. This one is a graduated tube or inner tube. Like this inner tube, the presence of this outer vessel present inside. Here this is the inner tube, or it is also known as a graduated tube, and this is known as a rose head. This is known as a rose head, and this is the it is a straight line. Use scale and pencil and draw this diagram. It is a straight. Okay. Here it can be a straight. This is crossed here in this diagram, and this is a thermometer, and this one the outside here, this is the outer vessel. D, it is denoted as D. Okay, first in the land burgers method, this apparatus is a land. This instrument is, or this apparatus is a land burgers apparatus. And here in the land burgers method, the land burgers method, the vapors of boiling solvent. Here your heating takes place here. This is the heating. The flame is present here. Heating takes place here. The vapors of boiling solvent, the presence of solvent, the vapors of boiling solvent are used to heat the solution. Here the vapors of boiling solvent are used to heat the solution in this flask here. This apparatus consists of, if you explanation, this apparatus consists of a flask A here. You start from here to finally end to here. Okay. First one, this is a flask. It consists of a flask A. This is a flask A, which contains the solvent, which contains the pure solvent. And here, which contains the pure solvent. It consists of a flask A, which contains the pure solvent, and it is connected to delivery tube. Here, it is connected through a delivery tube to a graduated tube. Here it is this flask, the flask A, it is connected to the delivery tube through a graduated tube. This is a graduated tube or inner tube. The graduated tube B, it also contains a small hole here. This B is contained, it is also contained the small quantity of solvent, and in outer vessel it contains a small hole. Here it contains a small quantity of the solvent, a small hole towards the top of the graduated tube. Here this is towards the top of this graduated tube. Here the top of the graduated tube, the small hole is present, because here the small hole is present, is escaping of the vapors here. A small hole towards the solvent, small hole towards the top of the graduated tube. It permits its communication with the outer vessel. It is the small hole is present here. The small hole is present here because of this communication takes place with this outer vessel. The communication takes place with the outer vessel. And a condenser is attached here. The condenser is attached, helps to the condenser. The condenser is attached here. It is helping to the condense the escaping vapors. A here, and also the thermometer is connected. The thermometer is lowered in the tube B. This This is a tube B. It is denoted as tube B. The thermometer is kept lowered in the B here in a graduated tube, and here it is kept well within the liquid air. It dip in a liquid way. Liquid. This is presence of here liquid, and this here the flask A enters the graduated tube. Here the presence of solvent in the flask A. Here flask A contains the solvent, and when transferred into or it enters the a stream of the solvent from the flask A enters into a graduated tube B and condenses. The latent heat of condensation rises here. The latent heat of condensation when it is the when presence of flask A solvent, the solvent is enters into the graduated tube and it is condenses, and the latent heat of condensation rises the temperature of the solvent to the boiling point. When here it is rises the temperature of the solvent to the boiling point. The solvent gets a boil, it get a boiling point when the temperature remains constant. After the temperature is changes varies, it is transferring to entry of the graduated tube from the this solvent. It is entry of the graduated tube. When it condenses here, condensation takes place and rises the temperature of the solvent to the boiling of the boiling point. And when the temperature remains constant, it is noted, and this when temperature remains constant, this gives the boiling point of pure solvent. When temperature remains constant, it gives the boiling point of the solvent. Boiling point of the solvent. Okay. Then this is repeated. This whole process is then repeated. The difference boiling point, then finding the boiling point of the solution. Solvent is finding and another solution is finding. This difference between these solution and solvent is known as the elevation of the boiling point. Here, the weight amount of finally you get a it remains a constant temperature. It gives a constant temperature, or when the temperature remains constant and it is noted, or this gives the boiling point of the pure solvent and a weight amount of the solute under examination. Here is the solute under examination, then added into the tube B, then weight amount of solute. Then it is added into the this graduated tube, or it is a inner tube, and the process is repeated. This process is repeated from the entry of the solvent into the graduated tube until the temperature again constant. This gives the boiling point of the solution. Second, the weight amount of solute is added in the graduated tube and the entry of the solvent into this inner graduated tube until the whole process is repeated until again the temperature remains constant. It gives the boiling point of the solution. First gives the boiling point of the solvent and second gives the boiling point of the solution. And the volume of the solution is read off here. The volume of the solution is read off at this stage, knowing the density of the solvent. At this stage, you produce the boiling point of solution and solvent. At this stage, knowing the density of the solvent and the mass of the solvent, density of the solvent and mass of the solvent present in the solution can be calculated. Mass of the solvent present in the solution can be calculated, and these two temperature, one first temperature and second temperature, boiling point of the solvent and boiling point of the solution. This difference between two boiling point gives the boiling point elevation delta T, and the molecular mass is calculated using equation. I already given the equation finding or calculating the molecular mass. Here the molecular mass using the equation is m is equals to, here the determination of elevation of the boiling point by land by this method, and next and the equation for finding the molecular mass. Here m is equals to 1000 kb small w divided by delta t into capital W. Use the finding the molar calculation of molecular mass result here. That is m is equals to 1000 kb w divided by delta t into capital W. After here, you write in your examination, and this question is also 5 marks question. This is very important 5 marks question. The colligative properties. In colligative property unit, this determination of elevation in the boiling point by land this method is very important question. Not this one only, the whole unit is important. I am repeating repeatedly. This is important. This is important because of this. The whole chapter is very important. Okay. I stop here in the class. Okay. In next class, I will discuss the relationship between the relationship between, or it is a derivation or expression here, the relationship between the depression in the freezing point. In last class I discussed the derivation of the elevation of boiling point. Here the elevation of boiling point is discussed, but in next class the derivation, the relation between the depression in the freezing point and the molecular mass, and also the lowering of vapor pressure. Relationship between depression in freezing point and lowering of vapor pressure and its molecular mass. The derivation is very important for 5 to 6 marks question. This is the need label. Neatly draw a diagram, and this is a rough need diagram. Thank you.